I was wondering if you could maybe teach me a little physics.
Number 10. Archimedes' principle, the toast derivation. Sheldon idolizes the greatest minds in history. One name that tends to pop up is Archimedes. Yes, the Eureka guy. In one notable example, Sheldon interrupts Zach's steamy story with an anecdote about the ancient Greek mathematician.
Because the crown was irregularly shaped, there was no way to mathematically determine its volume. But while bathing, Archimedes realized he could immerse the crown and measure the amount the water rose.
You might recall that tale from your school science class. A gold crown, a bath, density, and some serious brain power.
The Archimedes principle states that if an object is submerged in a fluid, then the buoyant force acting on it is equal to the weight of the fluid displaced by that object.
But according to physics whiz and science advisor on the show, David Saltzberg, a modern-day Archimedes might have considered that one could mix gold with denser materials. He also noted that if you bend the laws of physics, you could be sitting on a gold mine. Too bad the others weren't listening. They could have had their own eureka moment.
We are the intellectual descendants of Archimedes. Give me a fulcrum and a lever and I can move the earth. It's just a matter... I don't have this. I do not have this!
Archimedes would be so proud.
Number 9. The manstruation myth, the Wheaton recurrence. Let's clear this up straight off the bat. No, men don't menstruate. But Sheldon's right. They do have their own hormonal cycle.
What's with him?
Perhaps he's at a sensitive point in his monthly cycle.
Are you saying he's manstrating?
However, instead of monthly, men's testosterone levels go up and down throughout the day. It's supposedly highest in the morning, lowers as the day goes on, and rebuilds during sleep. Just like how the menstruation cycle can affect how someone feels, these rises and dips can affect men's moods and behaviors too.
As far back as the 17th century, scientists observed a 33-day fluctuation in men's hormone levels.
Interesting. That might explain my weepy days in the middle of the month.
But we don't think that's what Leonard's experiencing here. He just dropped an unreciprocated L-bomb. Who wouldn't be devastated? Still, if they're going to play on that age-old trope, then doesn't Leonard also deserve an ice cream treat?
I've been familiarizing myself with female emotional crises by studying the comic strip Kathy. When she's upset, she says, "Ack," and eats ice cream.
Number 8. Non-Newtonian fluid, the barbarian sublimation. In this Season 2 episode, the guys have a blast pouring a mix of cornstarch and water on a speaker and cranking up the tunes. What's utterly mind-blowing is that despite starting as a liquid, the mixture springs to life like a solid once the sound vibration hits.
Hey, check it out. It's just cornstarch and water.
This matter-bending magic is the work of a non-Newtonian fluid, a substance that defies the rules, switching between solid and liquid states depending on its environment.
Joe is running on top of a mixture of cornstarch and water. It's a liquid, but it acts like a solid when we apply force to it. If Joe stops moving, he'll sink right in. Stop, Joe.
Apply some force and it stiffens up. Relax the pressure and it's a liquid again. There are tons of cool DIY experiments online, and you only need 2 simple ingredients. Penny might not be impressed, but we sure are.
They make up a non-Newtonian fluid, which is liquid, but solid under the percussive action of the speaker.
That's what makes it get all funky.
Yeah, okay.
Number 7. A jellyfish's life cycle, the 10-year turbulence. During lunch in the cafeteria, Leonard shares this cool fact. There's a type of jellyfish, the Turritopsis dohrnii, that's practically immortal.
I was reading about this jellyfish that never dies. Instead, it reverts to its asexual state and then grows up again.
While regular jellyfish succumb to old age, stress, or injury, these remarkable sea creatures have a fantastic trick up their tentacles. Instead of dying, they shrink, settle on the seabed, and magically turn back time, starting their life cycle all over again.
After it reaches its mature adult stage, it can revert back to the polyp stage before growing into an adult once again. Potentially, this can be repeated indefinitely.
It's a bit like the mythological phoenix rising from the ashes. But imagine a superhero with Turritopsis dohrnii superpowers? That would be pretty neat. This fun fact leads the group to contemplate a reality where immortality exists.
My point is, immortality is not only a possibility, it is real.
Only if you're this jellyfish, which periodically reverts to a mass of undifferentiated protoplasm.
If I could keep my Gmail account, I'd be okay with that.
Honestly, we're just surprised no one makes a Doctor Who joke.
I know these teeth. What?
Number 6. Where do you keep your bread? The Cornhusker Vortex. Ever wondered where to store your bread? In a bread box, a sealed container, or perhaps the fridge like Penny?
There's some in the fridge.
You shouldn't keep your bread in the refrigerator. Staleness is caused by crystallization of the starch molecules, which occurs faster at cool temperatures.
On Earth, we'd say thank you.
Sheldon tells her that she shouldn't keep her bread in there, as it could cause it to go off faster. And guess what? He's not wrong. Keeping bread in the fridge makes it go stale quicker.
And not longer. And when the heart stops, you stop breathing and your brain shuts down, and that's how we declare people dead. And that's why we give a time of death and we give them a note. And really, to be honest with you...
Why? Flour has tiny starch molecules. When baked, they make our bread soft and tasty. But as it cools, these molecules restructure, making the bread hard and less moist, and can compromise the flavor. If you ask us, it's Penny who should be thanking Sheldon. With his advice, she can enjoy fresher bread and save some extra dough. Number 5. Game theory. Various. The mathematically inclined among us may have already noticed that Sheldon and Amy's relationship plays into game theory.
I'm not upset with you, but Amy's pretty bent out of shape, so she hired me to let you have it.
Well, I suppose turnabout is fair play.
You darn right it's fair play, you selfish jerk!
What's that, you ask? It's like playing a game where you plan your moves, think about what others might do, and try to collaborate smoothly. While it might not sound very romantic, it's about thinking ahead and making predictions without getting into complicated math.
Game theory applies to games involving 2 or more players. In a game, players share common knowledge of the rules, available strategies, and possible payoffs of the game.
Sheldon and Amy often face situations where they have to consider each other's feelings and make decisions that impact both of them. They, arguably Amy more than Sheldon, try to balance their own desires with what's best for their relationship. They even find themselves caught in a prisoner's dilemma while planning their wedding.
Wedding toasts in Latin.
Great! Vows in Klingon.
Then I'm changing the flower girl to a dog. And guess what he'll be scattering instead of petals?
Number 4. The properties of graphene, the Einstein approximation. In this episode, arguably best known for this scene, Sheldon agonizes over trying to understand why electrons exhibit weightlessness while moving through graphene.
I don't need sleep. I need answers. I need to determine where in this swamp of unbalanced formulas squatteth the toad of truth.
Graphene was a hot topic in the physics world in the mid-2000s and early 2010s. But what is it exactly? Well, in 2004, 2 brilliant minds, Andrei Geim and Konstantin Novoselov, managed to extract an ultra-thin layer of carbon atoms using just a regular pencil and everyday sticky tape.
It has the same carbon structure as the graphite you use every day when you draw or write with your pencil. But at the same time, in 0.03 inches of graphite, there are about 3 million graphene layers.
Even though it's super strong, this material is so thin that you can't see it with your eyes. However, scientists think it has the potential to change our future by leading to amazing inventions. No wonder Sheldon is so determined to unravel its mysteries.
I've been looking at it all wrong. I can't consider the electrons as particles. They move through the graphene as a wave.
Number 3. The Doppler effect, the Middle-earth paradigm. Remember that hilarious Season 1 Halloween episode where Sheldon dresses up as the Doppler effect?
Sheldon, there's something I want to talk to you about before we go to the party.
I don't care if anybody gets it. I'm going as the Doppler effect.
No, it's not.
If I have to, I can demonstrate. Meow.
For anyone who missed it or doesn't remember, the Doppler effect is all about how sound or light changes when an object moves closer or farther away from you. Picture this. When a car zooms past, the engine sounds louder as it nears you and softer as it goes away.
Hey, what's Sheldon supposed to be?
Oh, he's the Doppler effect.
Yes. It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Why? Because the sound waves squash together as it gets closer, making it loud, and stretch out as it moves away, making it quiet. astronomers can also use it to detect shifts in galaxies.
So what are you supposed to be?
Me? I'll give you a hint.
Choo-choo train?
Close!
We could break it down for you more, but we think Sheldon actually summarizes it best.
I still don't get it.
Number 2, magnetic monopoles. The monopolar expedition and the electric can opener fluctuation. At the end of season 2, Sheldon and the gang gear up for a journey to the North Pole in search of magnetic monopoles. Mysterious magnets that could unlock the secrets of the universe.
If I'm able to detect slow-moving magnetic monopoles there, I'll be the scientist who confirms string theory. People will write books about me. The third graders will create macaroni art dioramas depicting scenes from my life.
He believes that could be game-changing for string theory, but unfortunately, things don't go quite as planned. But he's far from the only scientist on this quest.
It's the magnetic monopole. And of all the fantastical beasts of particle physics, this is perhaps the most likely to actually exist. So, where are they all?
Why are magnetic monopoles so important, you ask? Well, imagine them as rare puzzle pieces that can enhance our understanding of our world.
An ordinary magnet has two poles. The primary characteristic of a monopole is that it has only one pole, hence monopole.
Scientists have scoured for these elusive magnets like hidden treasures, but if they exist, they remain unfound. So Sheldon shouldn't be disheartened. He's not the sole explorer who's come back empty-handed.
In actuality, what your equipment detected wasn't so much evidence of paradigm-shifting monopoles as it was static from the electric can opener we were turning on and off.
Before we unveil our top pick, here are a few honorable mentions. Amy Farrah Fowler's real brain power, Various. Like Amy, actor Mayim Bialik has a PhD in neuroscience, so she really knows her stuff.
I'm doing research on emotions and brain activity, so when you start crying, I can see which region of the brain is activated. Then I'm gonna stimulate the analogous area in the brain of a rhesus monkey and see if he cries.
Glowfish, the luminous fish effect. Do you think Sheldon got his inspiration here?
Their color is actually a hereditary trait that comes from a fluorescent protein found in coral and other marine organisms. That trait was added to a single fish embryo many generations ago, and now glowfish are born with their color and carry it through their lifespan.
Neil deGrasse Tyson eclipses Pluto, the apology insufficiency. The astrophysicist called himself an accessory to the demotion of Pluto, so Sheldon's theory is totally on point.
I'm quite familiar with Dr. Tyson. He's responsible for the demotion of Pluto from planetary status. I liked Pluto. Ergo, I do not like you.
Penguins and monogamy, the Hofstadter insufficiency. Raj sure knows a lot about penguin relationships, the highs and the lows.
So, if the fact that your husband left you makes you feel unattractive, just remember penguins get cheated on, and they're adorable.
Number 1, Schrödinger's cat, Various.
Actually, I've heard far too much about Schrödinger's cat.
The Big Bang Theory made science accessible and engaging, especially for those of us who might have forgotten our school lessons.
No, it wasn't my cat. It was an experiment designed by this guy named Schrödinger.
From the Charlie Brown cartoons?
No, he was some kind of scientist. Let me start again.
If our teachers had applied scientific theories to everyday problems like Sheldon does for Penny, maybe we would have remembered more from those classes. But hey, for anyone who's here for the science but isn't much of a BBT fan, we'll let Sheldon catch you up.
A cat is placed in a box with a sealed vial of poison that will break open at a random time. Now, since no one knows when or if the poison has been released, until the box is opened, the cat can be thought of as both alive and dead.
Sure, Schrödinger's cat is used to help scientists unravel the mysteries of quantum mechanics, but as Sheldon teaches us, it can have real-world applications too. So naturally, the gang calls back to it on several occasions. Not only do we get a science lesson, but that's some great life advice too.
All right, the cat's alive. Let's go to dinner.
Did anything you learned from the Big Bang Theory help you in the real world? Show us your workings in the comments.